in your laboratory work. So let me give you like guidance on which chapter align best with your with the current project or with that, your experiment. So lastly, I would like to acknowledge and express gratitude to my research partner from Hokkaido University, Hokkaido Research Organizations, Nagasaki University, in Taiwan's National Sun Yat-sen University, and then from Thailand, Kasat University, Malaysia is University Kebangsaan Malaysia and University of Malaya. They give me a lot of support, not only of course the funding and then the preparation of the absorbent characterization and then some other aspect on the development of magnetic material that I do recently in the laboratory. And then also, especially for the great giant pineapple industry, they are a leader in the pineapple. They are leader on the market. They allow me to use some resources and then test my material into their wastewater treatment as well. That is very important chance for me to bring my laboratory work into the real application. Also, my biggest supporter, my students in here, but actually during this presentation is make me realize this is very old picture during the COVID-19, I think, like a 2012 or 2020 or 20 something. And then after I put this picture, I realized I need to spend more time with my student and take picture together. It is because this is the picture that I have. Okay, that's all of my presentation. Thank you for your attention. So I welcome your questions and comments. Thank you. Thank you to Dr. Lina.
Thank you so much, Satya, for really nice, interesting, and topic and interesting presentations. So I give the time to the audience if you want to ask questions to Dr. Satya about the green chemistry for sustainable water purifications, especially on the magnetic band. And I believe that he has shown us all of his excellent work, and I think you wonder what or you have questions on the topic, on this topic. You may write your questions chat box, or you may ask him directly by raising your hand. Or I can, start first while waiting for other to collect their thought. So first one, it's really interesting when you put only calcium carbonate, if I'm not mistaken, to create the calcium carbonate, if I'm not mistaken, right?
Yeah.
To create the hollow on the surface of your adsorbent. How to control I mean, like uh, size or the number of the hollow on your adsorbent. I mean, like do we have to consider the ratio between the raw material with the calcium carbonate, or just like cooking, just put whatever you want to get the hollow? That's the first questions. And then based on this one, do you describe, explain more or elaborate more on these pathways, because we have green arrow and then we have this uh, red arrow, and then ultimately I think you combine these two into this GOMA.
Okay. Yeah. To be honest, the first time when we create this material is like we put at the kitchen. We put all together. So I just put all the calcium carbonate as much as alginate can hold. So at the time I want to, how to say, I want to make it with my magnetic alginate is stable. So at the time I really curious how much calcium carbonate that can hold to that structure and can avoid the disintegrity. Then after that we do some optimize. So we do some optimization. For example, we optimize to the calcium carbonate and alginate ratio. We do the calcium carbonate to the magnetite ratio, and then we also did the ways that the types of the calcium carbonate is the bulk calcium carbonate and the nanoparticle calcium carbonate. We also anhydrous one and then not anhydrous one. We also do some experiment on that, and this that reported in this journal is the most effective one. And in here, I have a red arrow and then the green arrow. It's actually different pathway. Red arrow means contain the graphene oxide and graphite. The green arrow is only magnetic alginate bead with malic acid without the graphene oxide and graphite. Why I differentiate into two sections in here, because I want to evaluate the effect or the role of the graphene oxide in here. So at the time, you can see that if we include graphene oxide into the material, it will be more. They have the capacity will be increased rapidly compared to without the graphene oxide. We was just this. I separate these two pathway because I just want to. What is the function of graphene oxide in here?
But they showed similar performance, or which one is more effective to capture the
graphene oxide, of course, better performance. Yeah.
Oh, sorry, which one?
With graphene oxide.
Oh, with graphene oxide.
Yeah, the red one. The red one is better.
If I'm not mistaken, graphene oxide is tend to be hydrophobic, right? So it allows to flow on the surface of the water. Okay.
Yeah. So the graphene oxide, they have a planar structure. The planar structure tend to the hydrophobic, but they have organic moieties that the organophilics. Why I choose the graphene oxide, not the reduced one? Because that specific organic moieties, they will interact with alginate, so they can blend into the alginate structure. Then after that, the organic moieties on the alginate will interact with the organic moieties on the graphene oxide. Means that the organic moieties on the graphene oxide will not longer applicable for the absorption on the water. So the last one, they only have a planar structure. Because when we try with the reduced one or the purely hydrophobic graphene oxide, for example, another type of graphene oxide, it's very difficult to make it a blend into the to distribute equally or homogeneously into the alginate beads. That's actually strategy.
Okay.
Yeah.
Okay. And I believe after this slide, you showed us the oil release, if I'm not mistaken.
Yeah, this one.
Yeah.
Yeah.
So this is basically just release using, I don't know, what did you do to release the oil from the
in here
hollow surface?
Actually we compare. Actually, when we in laboratory we do like ultrasonications. So I have an ultrasonicator set up in my laboratory. So by using the ultrasonic force, so I force the oil droplet to release to the material, but it's incomplete. Still need the another solvent. So I put some small number of hexane. So I put small number to hexane. Hexane is force that oil to release from the material. After that, that hexane will bring all the oil together. After that, I evaporate the hexane by using the evaporator and then collect the hexane. I will get the oil. Then the hexane, I can use it for another regeneration. But still, it's lab scale, right? Difficult to bring that, because sometimes industry they don't want to complex or multi-step application. So that's why it need to be optimized, especially for this option. But as long as my experience, I think hexane is the most effective.
Okay. In my opinion, I think the industry wants the adsorbent or the catalyst is, you know, not as effective as possible, because if they have an effective adsorbent or catalyst, then the industry of catalyst or industry of adsorbent will be
Will stop.
yeah, will be collapsed. So yeah, I don't buy it. Uh-huh.
Yeah.
Yeah. Okay.
Yeah. But
Anyone wants to ask questions to Sanjay, because this is really interesting.
I hope you will not get bored of my presentation.
No. This is really interesting. Because I also did this magnetic, but I did once with the capping agent, so I used the starch also. But instead of but I think most of my capping agents really cover the surface of my iron oxide or my magnetite. That's why it's not really working. Like the performance of the iron oxide is not really good. It's not really good compared to uh, the one without the capping agent. So maybe there's something wrong with my method, but yeah, that we can discuss about that later. But now we discuss about your questions. Yeah. Uh, about the aggregations, the challenge of having this magnetic material. If I'm not mistaken, the use of the biomass, maybe you can move the slide on the earlier part, I think. The earlier part where you showed us the part of the leaves or the part of the plants. Yeah, this one. I think the flavonoid or noids or polyphenol, if I'm not mistaken, this is also has the role to stabilize the size and also the shape of your particle, right?
Yeah, but sometimes when they stabilize, it means they cover the active agent of they cover the magnetic surface, right? But in here, most of the how to say most of the recent experiment they use the extract, not the purified flavonoids or polyphenols. So
Yeah, that's
sometimes when they cap all together and then we cannot unsure which one or which combination or which ratio they capping. Of course, they prevent the agglomerations, but this is organic, easily to deteriorate time by if you apply on the acidic or basis or during the experiment of the absorption, since flavonoid, terpenoids, polyphenols also not so stable. So when you synthesize, it's stable. But when during the absorption, they will agglomerate each other, depend on the situation or condition of the experimental setup you use. Not as stable as inorganic one. So of course, what is that? It's of course still interesting. We want to move this to this direction, make it greener, but there is a lot of things to be optimized, especially if we want to achieve the product in here as good as the inorganic or the conventional routes.
Yeah, because I also use this extract solutions. Yeah, extract solutions. And, from one with the one is from pineapples. In addition with the leaves, and the other one is from the coffee bean.
Coffee beans. Coffee
Yes,
beans means
coffee
that the
bean.
chlorogenic acid, right? It will be make important roles. Chlorogenic, caffeine.
Yes, that. But for the coffee, the coffee one with the extra coffee, I use it for the degradations of plastic, of microplastic.
Okay.
Yeah, the
Pineapple probably enzyme bromelain.
Tapi
You
lebih
take.
mahal daripada
yeah. That's, I think that one is the, you know, the
Yeah, the same mineral on the
yeah,
reduction of the your material.
600 atau 700
that's correct.
Mm.
Okay, and about the future work, I
Future directions.
it's
Beda
yeah, future
fasilitasnya.
directions or the future work. Can you, like, maybe since you put this in the context of your presentations, I can you give us example on the smart AI enabled system? I mean, is it for example, sometimes when we want to check on the, like, you know, real-time monitoring means like during the experiment, or during the characterizations, because sometimes we use the, like, the in situ in situ things. So which um which aspect can we implement this smart and AI enabled system for the magnetic adsorbent in water treatment?
Yeah, okay. For the smart and AI enabled system, actually, is not limited to the implementation of the organic material, but also the synthesis process itself. I read probably several papers, and then I actually probably I was at the review. So the journal asked me to review one paper, the implementation of AI. They do the AI and then machine learning things to optimize the synthesis process. So we don't have to try and error and optimize this aspect. They just collect the data. After that, we put our mass ratio, and then they will create what is the perfect chromosomal moral ratio, and then electrolyte situation, pH, what time, and then they will predict like stability and also what is that? Crystallinity and then the structure of your material. So very interesting, right? I mean,
Yeah,
high computational things. It will
that's
reduce
correct.
our cost, trial error time. It will be reduced, so the process will be very effective. We can predict something that probably is impossible to be created in our laboratory. But of course, in the implementations, in the application of a magnetic material, especially if we want to use our material to be a sensors. So magnetic material based on the interaction and absorption with some pollutant, if they have a very selective and then they have behaviors and can detect very lower number of the some analytes, we can use it as a sensor. But in the sensor, the AI, it will possible us to like what you say, the real time monitoring. So real time monitoring, they will detect this water stream contains something with a higher than the regulated ones, and then some after that it will activate another wastewater treatment system, something like that. I think still idea. But one I saw in Singapore, they already implemented in what is that in system. They have a very integrated
Ini
water
setelah
system.
sempro
You
baru
know
ini
that
Bu Dian
Singapore
kesini
have a
lagi jadi.
very limited supply of water. They rely on
baru ketemu
Malaysia,
Bahan.
right? So they
Iya
that
dari kos kita
situation
di
they have
sana baru ini lagi dia
make
pindah
them
kos ke
focus
sini.
on the water treatment. They already set up this type of the water treatment, but because I just saw the presentation, I don't know in detail, but they
dua
do this
saking
direction.
lamanya.
Oh, that's really nice.
Yeah.
Yeah, really
Yeah.
nice. Because I haven't read about. I mean, like, I never cross with this kind of articles. Most of the articles that, you know, about the real-time monitoring, and it was only in the catalyst preparations, not in the implementations on, yeah, not in the implementation on how they use monitor or the water treatment facilities.
They do this direction.
That's really nice. Yeah, we really left behind in the terminology and the science.
Laboratory catching up to this.
Yeah.
Get more funding.
Okay. We have one question from Dr. Waton. He is your junior in the apa, Universitas Negeri Yogyakarta, you can say. Or Pak Waton, do you want to ask directly to Pak Satya?
Okay.
Yeah.
Hi, Mas Satya.
Oh, hi. It's been a long time. I think last time we met during our master program, I think, Dr. Lina?
Yes.
Yes.
Last time at UTM.
Yeah.
For the preparation for the master science. So I want to ask what your response. Actually, I'm really sorry that I didn't follow the whole presentation because one of the others. I was wondering when you highlight the slide presenting about the use of the extract from the plants as bioreactors for the to produce the nanoparticles. In your slide mentioned that it contains the flavonoid, polyphenols, and also terpenoids, and some plants, for example, from the seed or the leaves, they have contained the alkaloid as well. I was wondering, I know a little bit about flavonoid and polyphenols mechanisms, but I'm not quite sure with the alkaloids or the terpenoids class in producing the metal ions to produce nanoparticles. If you have any insight, that will be really helpful to understand the mechanism. Thank you.
Yeah, thank you.
Can you hear his question clearly?
Like,
Okay.
Flavonoid, terpenoid things, right? Actually, to be honest, my laboratory not focused on this route. So this greener road, actually, I reported based on the another researchers data. But why I highlight in my presentation in here, because I think it's important. We need to make it. Since we want to follow the 12th principle of the green chemistry, then we will go to these directions. But for the greener road, at this stage, people still focus on the utilization of the plant extract, contain the flavonoid, terpenoids, and polyphenols. That's why I mentioned before, since they have used the extract, right? They don't use the pure flavonoid or polyphenol or terpenoid. Or probably there are there are some journal, but I don't get across with that journal. That make the mechanism itself become unclear because a lot of substance in the extract, right? And then when you want to probably when researchers extract in the same plant, they will get another composition in that extract. So it's make it how to say reproducibility of this mechanism will be lower, and then the mechanism itself become unclear. That's why my laboratory, once we try, but after that still is still too far to be implemented in large scale. Then we stop. We move to another type of the extraction or synthesize. So, but with that, some researchers they report in these routes. So probably if you want to if you can find like what is that a clear pathway or clear mechanism, then it will be beneficial on the development of the greener router. I myself, we still with that use the another route to create my magnetic material because when I discuss with my partner industry, they don't really care about how we prepare our materials or how we get that material. As long as it's cheap, then industry will be happy. That's why I cannot control. Of course, it is cheaper, but I cannot control the quality of my absorbent. In other hand, if I use the conventional method, little bit higher, but I can control the properties, the behavior of material as what I expect. So that's why I still use the previous method, Dr. Waton.
Yeah, that's totally true. But true extract, but there's a lot of secondary metabolites. And
I'm sorry,
as
but
we checked earlier,
your voice is clear.
There are some competition. That's why I was wondering. Maybe there are some competition between flavonoid and alkaloid and terpenoids in terms of reducing the metal cation and reducing the nanoparticles. Based on my experience, when I use the simple compound of the flavonoid, for example, varsity, somehow it produces a smaller size of nanoparticles compared to the including extra. I was wondering because like you mentioned as well about the trapping agent, the impact of trapping agent, and also under toxic and natural products. I was wondering if there are some competition between those compounds has been studied for.
Yeah. Yeah. That's good. That's good.
Yeah. Thank you very much.
You're so welcome. Good luck with your research.
Yeah. See you later, my student.
Yeah, same. It's still you just speaking this time.
Okay, anyone else wants to ask? You can write using bahasa Indonesia.
Ya, pakai
karena Pak Satya juga dari Surabaya aja. Mau pakai bahasa Surabaya juga boleh.
Boleh.
Boleh. Toxicity. Why toxicity is because right? Like if it's not nascent, the toxicity is not really or is it important of the side we're talking about?
Ya, itu even totally nasty. Sometimes do we before the toxin itu also be a benefit of our material. Of course, this is doing environmental, they have like process, solution, disintegrity, they will change structure in the environment, right? So sometimes in the end, they'll how they are more active or anything else from our topic, material. Pada the house probably some structure changes, or maybe your material is not so stable, and then every material interact with our tissue. So some of that things will happen. That's why if we want to prevent testing, because we cannot predict what will happen with our material, so better we study to evaluate the toxicity to make
Nanoparticles. I'm not during my experience, they don't really dissolve.
Yeah.
But now that hearing from you that all the all the material may cause some harm, even if it seems safe. So yeah, we have to consider toxicity.
Yeah, since they still have limitation, especially in the stability here I mentioned, and then after the big generation issue, especially if you cannot collect 100% of the material you release as an absorbent, so it's still a chance, right, that some part of your total absorbent is released to the environment, and we cannot control what will happen in the environment. So that's why to minimize that side effect, we just want to create a safer, with the magnetic material. Prior to the bad things happen. That's why toxicological evaluation in here need to be done. If you really want to get the whole data completely.
Yeah. Okay. And then so if this is the maybe last questions, I think before I sum up your talk. So your opinion, how advanced will the magnetic adsorbent will will go or will grow to be one of the, I don't know, one of the solutions for the environmental issues.
Yeah. Okay. So actually, when we create the absorbent or especially magnetic absorbent, we don't aim to, how to say, to replace all this conventional wastewater treatment completely, but we want to make that material works very effective and efficient to make this conventional wastewater become smarter or become the, how to say, become
Simpler.
yeah, of course, and then we can cut the cost or something and energy. That's why it will not, of course, will not replace all the system here. It's still effective in the larger scale. That's why I mentioned before integration with another topics or in another technology will be continued in the future, especially if we can create material ways that also serve with the as another ways that function. So the multi-functionality of your material is important. You want to make your materials with a simple preparation, high performance, and also multifunctionality. I have one collaboration that ways that integrate between the catalysis and advanced oxidation. I'm not sure, and then we want to work with that. So it's magnetic, so we can collect the materials after in the end of the process, and then some one of my research partner also want to make a create a membrane for the detections. So it means that maybe the application of the magnetic material not limited in absorption in the larger scale, but also serve as a part or another advanced system. That's why we need to find if we want to design our material. That's why we need to check what method or what technology that we implement, then what requirements is essential. Then after that, we design our material based on that requirement. So probably you don't need what is that functionalization, but another aspect you need functionalization. Sometimes you just need the very stable and then pure and then high homogeneous material without any functionality. It will work well as a catalyst, for example. Then you don't need any functionalization. But for example, if you need magnetic material as a without the sensors, you need the certain aspect or multis that will interact with the analyte. Then functionalizations need to be conducted. So it's depend on what technology. Once again, it's depend on the technology that magnetic material will be implemented. I think this material will also still expected to be developed. If not so prospective, maybe I need to stop my research in this in this topic and another topics.
Another topic.
Yeah.
Okay. Ladies and gentlemen, we still have 6 more minutes. Do you have any questions on the magnetic adsorbent in water treatment? Or you can, maybe if you are interesting, but you are too shy to say something, maybe you can directly email him. Can you show us your email address?
I just write in your.
Yeah, please. Write on the chat box, or you can in the chat box, Dr. Satya.
Okay. Wait.
You can write in the chat box. Yeah. So.
Okay. I will type my email here.
Yeah. Please do so. Type.
That's much.
Yeah. Okay. So that is the email address of Dr. Satya. If you want to discuss more about or you are interested in his topic, and I think he also have other work beside this magnetic adsorbent. So feel free to contact him, and hopefully he will write back to you because he's really busy. He's a very important.
I will be very
He's
happy.
very It's very important. That's my sensei said. So before I close this third sessions, I would like to wrap up with some of the summary that the green chemistry for the sustainable water purification is still have a lot of for the improvement and the advancement in magnetic adsorbent, which already explored by Dr. Satya, will still have a lot of room for improvement. And because,
Gantian aja Muna.
like he said, that the industry
Iya.
wants
Gantian
simple,
sendal.
cheap, but multifunctionality
Nyeker.
adsorbent or catalyst, which is maybe
Sama kayak
a
37. 39 ya.
difficult for the uh, research
Cepat.
and industry. It's not really matching each there because they want some cheap and multi-purposes adsorbent, but in reality, as Dr. Satya said, that one functional material may not be able to replace the complexity of the real water treatment.
Yeah.
Once again, thank you much, Brother Satya, for a really nice, interesting, and insightful presentations. And would you mind to and then here is the token of appreciations from the bachelor program of chemistry educations, and also the committee of chemistry education and chemistry summer school virtual lectures. Once again, thank you so much, Dr. Satya. We will see again in different time and opportunities and also events. Thank you so much, and I will give it back to the MCs.
All right, thank you so much for Dr. Satya for the insightful presentations, and thank you for Dr. Lina to lead the sessions. Okay.
Now process with the assignment session. Session will help participants deepen their understanding of today's materials.
Ini gantian kah saatnya?
Aku mau minjem sendal, tapi sendal Bunana 37. Kakiku 39, iya.
Ada
Bawa. Ada 2.
Ibu itu belum? Belum. Oh ini ya.
Alright, this is guideline for the assignment sessions. First is please rename your account with these following rules: institutions underscore name. For example, UNS underscore Anita. And then the second, please go ahead and pick one breakout room to join. Make sure that those rooms contains multiple institutions participants. And third is sharing sessions. If you are to do a collaborative with your new friends, what is the topic that you pick?
Alah, ada assignment pula.
Okay.
Contoh butuh
And this is the guideline. You can use these example questions to help you discuss. First, what local environmental problem in your area could be solved? using chemistry. Can you think of any ways matters around you that could be turned into something useful? And which SDG goal do you think is most urgent in your community? And how can science? Now you can go to the breakout.